So now we want to see how to do confidence intervals for the population mean. And so I'm going to do a couple of problems from the book. The first problem we'll do is actually one of the practice problems at the end of the chapter. And then we'll go ahead and we'll do one of the examples from the book. Okay, so I'm going to go back. I have a template for the population proportion. I'm going to copy and paste that because a lot of the formulas are going to be similar. So I'm going to go ahead, I'm going to copy this, and I'm going to create a new sheet. You can just click on the little plus sign here, and I call this template for mu because this is going to be the confidence interval for the population mean. And what I'm going to do, I'm going to be really careful here. I'm going to paste with formulas. And what that means is that all the formulas I use to compute these quantities are going to go over. If I paste as values, it's really useless. I've wasted my time. And I'm going to change a few things, okay? Here I'm going to need the standard deviation of my variable. And again, I'm going to have both a calculation for a summarized data set and a raw data set. I'm going to have the sample size. Here my estimator is not the sample proportion, it's the sample mean. So I'm going to have mu hat. The confidence in the z-score will be computed the same way. The standard deviation of the distribution is now going to be the standard deviation of the variable divided by the square root of n. So I'm going to have to change that. Okay. Margin of error will be computed the same way, so will the confidence intervals. So let's see how this works. So we'll split the screen here, and this is on page 218. So Bardo is still at this problem where he's baking his loaves of bread, and he wants to see if his machine's operating correctly. In other words, he doesn't want it making loaves that are too heavy because then he's going to lose money, but he also doesn't want it making loaves that are too light because then he's going to be ripping customers off, right? And so he goes ahead and he takes a random sample. So he takes a random sample of 36 loaves. So I have 36 here. He finds out that the average weight is 16.3 ounces. So this is going to be my mu hat. And the standard deviation of those 16 loaves is 0.6 ounces. So this is a standard deviation of his data set. Okay. This is all the given information. He wants a 99% confidence interval. There's a 99% confidence interval for the population mean. So notice that automatically changes. Now the standard deviation of the distribution. So we want to remember that this is equal to the square root of the standard deviation divided by the square root. So I'm going to have to change this a little bit. So my standard deviation of the variable is this, divided by the square root of the sample size, which is this. Okay. And I should get 0.1 when all the mathematical smoke clears. Okay, so remember the standard deviation of the sample mean. The sample mean has its own distribution, right? It's a normal distribution. So the standard deviation of the sample mean, it's related to the standard deviation of the data. It makes sense. If the data is really spread out, the estimators are going to be spread out, right? So it's the standard deviation of the variable, which here is 0.6, divided by the square root of the sample size. Again, as the sample gets larger, right, the estimates get more and more clustered. They get more tightly clustered, which means that the width of that distribution measured by the standard deviation is going to go down. And there we go. Okay, our margin of error is computed the same way, and our confidence interval is computed the same way. So nothing there has changed, okay? So all I had to do is just change a few cells up here. So the parameter of interest we know is the population mean. Our point estimate is the sample mean. That's the single value that best estimates the population parameter. Does his sample satisfy the conditions? You have to make sure that this is true. If it isn't, all these calculations are baloney. They're useless. Okay, first of all, I need a sample size of around 30, and I have 36. Moreover, I know that deviations are kind of normally distributed, right? Errors that when we're looking at things boxes being filled or weights of things and stuff like that, those errors tend to have a normal distribution. And we have a random sample, so we've satisfied all the conditions. Our 99% confidence interval is the following. I'm going to reduce the number of decimal points. It just gets confusing. So Bardo is 99% confident that the average loaves of the bread made are between 16.6 ounces and 16.0 ounces. Okay. Now notice he should be concerned, right? He doesn't want the average being more than 16. So this is evidence that there's something going on, that the machine's not working properly, right? If we did a hypothesis test to see if it's different than 16, right? We'd have to be a little careful. We'd have to now actually probably put this out to 2 decimal places because we're on the cusp here, right? So let's put this out to a few decimal places here, okay? So we see that if Bardo ran a 2-tailed hypothesis test to see if the average weight of all the loaves was 16 ounces or different than 16 ounces, he would have to reject the null hypothesis. He would have to conclude that the machine's not making loaves whose average weight is 16 ounces. Okay, so that shows us how to do confidence intervals with summarized data sets. What if we have a raw data set? So I want to go ahead now and I want to look at example 2 on page 206. So let's scroll up a little bit here. It's example 2. It's up here a little ways. Here we go. So this is the Craigslist Daytona Beach apartment data set. So this is an actual data set that I did a while back. And basically what we want to do is we want to get the 99% confidence interval for the average rent. And so I'm just going to go ahead and open up the data set real quickly here and import it into Excel. It's a little on the big side. Download that Excel. Basically, everything's going to be the same. The only thing I have to worry about is I have to compute the sample standard deviation. That's really all I have to do. Let's see, it's right here. So from the, so first of all, I'm going to have to do a little bit of work. I'm going to have to inspect the data. I can't just rush in and start computing numbers, right? So when I kind of look at all these things, right, this is what I'm interested in. I'm interested in the apartment price. So I'm going to go ahead. I'm just going to highlight that column. I'm going to sort the values. They're probably already sorted, but just for the heck of it. Okay, go ahead and sort them. We can do smallest to largest. Okay, 500 for an apartment. It's possible, right? They're not too easy to find, but it's possible. Maybe an efficiency, whatever. All the values look okay so far. I'm not seeing anything too far out of line. $2,000 for a condo, that's nothing really, right? So my data values look valid. I'm going to go ahead now and I'm going to compute the sample standard deviation. And I have 121 data values. Okay, so I can go ahead and I can write down my sample size. It's 121. And I'm going to need the sample mean and the sample standard deviation. So I'm just going to go ahead and compute these right here. So stdev.s. Always remember to use S and not P. S is for sample. Okay. And we get 268.46. So I'm going to go ahead, I'm going to copy that, and I'm going to paste that as values. I don't want to paste that as formulas. If I do, it's going to give me an error, okay? So here I have to paste as value, okay? I also have to compute the average, and so I'm going to use the same thing. I'm just going to change this to average. Oops. I'm going to use the same range, of course. Come on. I'm just going to type it in. So the average apartment place is 950. Again, I'll just copy and paste that. Again, that seems reasonable, right? So we'll go ahead and just paste that. And I did the wrong thing, right? I didn't paste as values, okay? Because I got distracted by the phone. Okay, so let me do it again. Copy it and paste. Come on, there. Paste as values, and I'm okay. And now everything else goes right over. I can basically just. And in fact, I happen to want a 99% confidence interval. Make sure that you change the confidence level, okay? Again, everything changes. I should probably check the standard deviation just to see if it makes sense. Okay, it's kind of large, right? So it's around 260. Square root of 121 is 11. So yeah, that looks about right, right? It's roughly 260 divided by 10, around there. I mean, I should get around 26, and I do. And again, I can just pull all these cells over and it automatically does everything. Again, how do I interpret this? I am going to round this off because we're looking at financial data, so it doesn't make sense to talk about three decimal places, right? And actually, I'm not going to put this in terms of numbers, in terms of currency, because very often you're going to be working with things that aren't currency. But this means that I'm 99% confident that the average price for an apartment advertised on Craigslist in Daytona Beach is between, roughly $887.50 and $1,013. Okay, I mean, you could put the exact cents in if you want, but it's not that big a deal. You might want to round that off to the nearest dollar. What would happen if I changed the confidence level? If I made it 95%, would the confidence interval get bigger or smaller? Well, if I want to be less confident that I contain the parameter value, I'm going to make the margin of error smaller, right? And therefore the confidence interval will get smaller too. And you'll see that. Look at the margin of error when I change this. With 99%, it's roughly 63. And when I hit enter, you're going to see this number change from 63 to 47. Okay, so the higher the confident, more confident I want to be I contain the parameter value, the wider the confidence interval has to become, the bigger the margin of error. Let's do a quick sample size calculation, okay? There's a problem in the book. We'll just do that really quick. We notice what our sample size calculation formula is down here. So it's essentially, again, you could take the estimate for the standard deviation, or you can use the range. Either one's okay, just depending on what you have. Again, I'll use this. I'm sorry. You have to actually use the range. This is the standard deviation of the estimator, not standard deviation of X. So I'm going to use the range. I need the z-score, which I can get from the confidence level, and I need the margin of error. Okay. So here, I'm going to have to add one extra thing, the range. And in the problem that we're given, Here we're told that we want a 90% confidence interval for the average height of all Embry-Riddle students, okay? So our margin of error is 1 inch. What is the range? Well, let's just use common sense, okay? Let's assume people can go from 5 feet to maybe 6.5 feet, right? So that's 18 inches, okay? And again, it's a little subjective. That's okay. My confidence interval is 90%. So I put 0.9. Again, I compute the z-score the same way. It's norminv.s. And I'm going to add 1 to the confidence level, divide it by 2, and do that computation. Okay? So how do I get the sample size? Well, let's look at the formula, okay? The formula says it is equal to the range. Try to blow this up a little bit. The range, which is 18, times my z-score, divided by, and I have to be careful, there's actually 2 things in the denominator, so I have to put a parentheses around these, okay? If you don't, you're going to get the wrong answer. In this particular case, if you didn't put the parentheses, you'd probably get the right answer because the margin of error is 1. But of course, in general, it's not going to be, right? And then I square that whole thing. And I need a sample size of roughly about 25, which I know I'm going to get because just to satisfy the central limit theorem, to do this calculation requires the central limit theorem is true. I need at least around 30. You know, it is, the heights again are kind of normally distributed, right? So I don't have to even worry about the sample size. That's going to be automatically satisfied. Okay, that's pretty much all there is. So save these 2 templates, and then on an exam, again, on homework, you can just pull them out, change the values. Just be careful that you do the changes correctly and you change everything. A lot of times people don't change the confidence level. They forget to do that. Okay, and that causes problems. But that's pretty much all there is to it.